Well, I think we're going to go ahead and get this thing started. Can everybody hear me okay? All right, good times. Uh, so I just want to let everybody know real quick that I am going to be recording this. That way, folks who aren't able to tune in can still kind of get some idea of how to work these things. Let me flip my camera around right quick. Excuse me. Okay, so this paper right here, Bronsted Lowry Acid Base Chemistry, this is one that we had actually taken a look at back before the break. So if some of it looks kind of familiar to y'all, there's reason for that. We'd started talking about how when you're looking at a Bronsted-Lowry acid and base, the acid was defined as the substance that donates the protons. Okay. And a proton, for our purposes, is just going to be a hydrogen ion. And you can think of it kind of like a ball. Okay. And what's happening here is that the substance that's the acid is going to be throwing the proton over to the substance that's the base. Okay. Our base is going to be whatever substance is going to accept those protons. So it's kind of like the catcher. Now, the thing about that, though, is that after the proton gets thrown over to the base, then the base is going to become what's called a conjugate acid. And the reason is he's got the ball now. And our acid is going to become something called the conjugate base. Because in most of these reactions, what can happen is that this new substance, this acid, can end up actually throwing the ball back over, which of course then would reverse things. It would change this substance, the conjugate base, back into an acid, and this thing that was the conjugate acid, since it threw away that ball, it threw away that proton, it's now going to be the base again. Okay. And again, if you've heard this before, it's because we talked about it before break, but it's been a while. So let's take a little bit closer look at this paper right here. And what they give you on each one of these lines right here is they give you bits and pieces, and they expect you to fill out the empty missing stuff. On the first line right here, HCl, hydrochloric acid, is acting as our acid. NH3 is acting as our base. So since our acid is the one that's got that hydrogen, it's got that proton, it's going to throw it to the base. And if you take a look here, after this NH3 catches that hydrogen, it becomes NH4, and it's got a positive charge because that proton has a positive charge. What was the acid, HCl, is now just chlorine, and it's got a negative charge. I'm not sure how well that little negative copied over there. And then here's our equation. And it's going to kind of follow this format. Your acid plus your base is going to yield your conjugate base plus your conjugate acid. Okay. Y'all feel free. I don't have anybody muted on my end, so if at any point you've got a question, just speak up. We'll hear you. Okay, so let's look at another one here. Let's jump down to number 4. I don't think we've worked number 4 before. So in this one, they don't give us the acid. What they do give us is the base. And so what we've got to imagine in order to figure out what the conjugate acid would be from that is if we were to add another hydrogen ion to this, what would it make? And right now it's OH with a negative charge. If we added another hydrogen ion to it, then we're going to have 2 hydrogens and 1 oxygen. And the charge, since we have a negative to start with, we're adding a positive to it. Total charge is 0, so we don't have to write positive or negative anything here. Going backwards, they don't give us the acid we start with, but they do give us the conjugate base. And so we can do the same kind of thing. This is CO3, and it's got a charge of -2. So if we were to go back in time and imagine this guy before he threw a proton away, it would be like adding a hydrogen to the front of that, and it would be HCO3. And instead of having a charge of 2 negatives, if we were to go back in time and add a positive back to it, then it's just going to have a charge of 1 negative. Okay. So is anybody else frozen up? I've got somebody who chimed in and said that everything is frozen up on their end. Okay. It's also telling me that my internet connection is unstable, so it might be something on my end. Give it just a minute here. Okay. I'm going to try to mute everybody and see if that has any effect on things at all. Okay. Anything looking any better? You've been looking at a black screen the whole time. Okay. Dawson, down there at the bottom left, you should have 2 buttons. One of them looks like a microphone. One of them looks like a camera. You should be able to click the camera button, and it should say, okay, it says the network bandwidth is low. I'm not sure if that's something that's on my end or if that's something that's on y'all's end. If it continues to give you a hard time, what you may need to do is just wait and watch this recording later on. I'm showing some halfway decent internet on my end, so it could be something at this end, it could be something at your end, it could also just as easily be that the Zoom website is getting quite a bit of traffic these days. Dawson, have you had any luck getting anything to show up? Okay. Okay. Is anybody else seeing a paper that I've been writing stuff on? It looks like one of the ones that was in your packet. Okay, Riggs has a black screen right now. Let me go check the chat. Okay. Lula says it was just frozen on your hand, but now it's black. That's been happening to a lot of classes yesterday and today. And you have a black screen now. Let me try and swap cameras real quick. Okay, what are you saying now? Hello? Complete black, just black. Black. Okay. I'm going to try to end the meeting and then restart it and see what happens. Okay, so y'all hang tight. Okay, for those of you watching this video, it's probably a mess. We've got some technical difficulties going on, it looks like. Wait and see if anybody else pops in here. I'll go ahead and stop this video.